Hello, everybody. I thought that there was going to be a presentation thing here, but that's all good. I'm here to, oh, there we go. Today, I'll be sharing my project, an AI-powered chatbot for pathogen genomics, education, and support. In short, this work explores how AI can be used to make genomics education more accessible, responsive, and scalable. To start with the challenge, the why, pathogen genomics is a rapidly growing field and essential for outbreak tracking and understanding how diseases spread. But the reality is that specialized training and expertise in this field are still limited, especially across resource-constrained regions. Even after formal training, many learners still struggle to apply theoretical concepts to real genomic workflows. The NGS Academy Help Desk provides a help desk, but this help desk relies on human and manual control, and with increased number of people, more queries, more buildup of unanswered queries. So the solution, I've been working on an AI-powered chatbot, which provides real-time support to genomic learners. To achieve that, I set out 4 key objectives. First, to collect and curate a high-quality literature corpus. Second, to build a semantic knowledge base that understands meaning, not just keywords. Third, I want to integrate it into the help desk. And fourth, to collect feedback for continuous improvement. Methods. So we get the data, we clean it, we extract it, we embed the data, and we index and design the retrieval mechanism. So, simplified overview. We started by downloading and cleaning full-text articles from PubMed Central, utilizing their FTP. These articles were processed and cleaned. After cleaning, I divided the data set into thematic categories, things like pathogen genomics, NGS, and phylogenetics, based on their keywords. Each data set was then converted into semantic embeddings, which is a numerical representation that captures the meaning of the words, and rather than just keywords. So the chatbot uses what is called a RAG pipeline, which stands for Retrieval Augmented Generation. So when a user submits a question, the system searches the index for the most relevant text. It then passes that context plus the embedded question to a language model, and then generates an answer grounded in that retrieved information. So this helps reduce hallucinations and improve accuracy, because the response is based on the actual retrieved content and not actually on what the model is trained on. So then I wanted to design a chatbot interface that is simple and intuitive. Users can type the question, see the answer, press a feedback button, that answer and that question is then stored in a log file, and we can use the unhelpful and helpful ones in the future to improve the general chatbot. And then, importantly, it also provides the source context, so which papers it used, what title of those papers, the PubMed Central IDs of those papers, so that learners can go and follow and check out those papers and see for themselves if the answer is bogus or not. So the results. To evaluate the system, I tested the chatbot on category-specific question and answer datasets. I focused on 3 metrics: retrieval accuracy, generation quality, and response latency. Exactly how it finds the information, how accurately it answers it, and how fast it responds. There were 2 scoring mechanisms that I've used so far, the BERT F1 score and the Rouge L score. BERT F1 measures how well the answer captures the meaning from the question, and then the Rouge L checks whether the chatbot has copied what the answer is. So this is an example. The question asked about transparency in animal experiment approvals. The chatbot's answer captured the same ideas as the human written reference, discussing public understanding, ethical oversight, and publishing rationale, but in its own words. So, across all 5 knowledge bases, the chatbot achieved an average BERT F1 score of around 0.84. That's considered a strong level of semantic alignment, meaning that the chatbot reliably understands and reproduces the intended meaning of the scientific context. The Rouge L score averaged about 0.12, which may sound low, but this is exactly what we want here. It means the chatbot doesn't rely on copying phrases from the literature. Instead, it paraphrases. Together, these 2 metrics, high BERT and low Rouge, show that the model understands, interprets, and rephrases complex ideas effectively. In terms of efficiency, the system generated responses in roughly about 2 minutes on my local hardware. The response times are longer than ideal, but that's expected given the constraints of running locally on my laptop. The encouraging part is that the pipeline will scale well, meaning that on an HPC or cloud infrastructure, these times would be reduced. When we look across all categories, the chatbot achieved a success rate of around 94%, meaning nearly every answer reached the high semantic accuracy threshold, which is BERT score greater than 0.8. It's performing well as a prototype, though there's still room to improve the retrieval precision and handle out-of-scope queries more gracefully. The next stage would be the user testing, so I'd be running a pilot study with trainees and researchers, gathering their feedback and using that to improve the interface and the underlying retrieval mechanisms. The step is essential because even the best performing model needs real user data to become genuinely effective in an educational setting. So, in conclusion, what have we achieved? What does it mean? What's next? So we've developed this RAG chatbot trained on open access pathogen genomics literature, showing high semantic accuracy across multiple categories so far. Early results suggest that it can synthesize and explain complex bioinformatics concepts in real time, hopefully helping learners work more independently. Further work will still focus on improving retrieval, expanding the data sources, and adding multilingual support. Thank you. Yeah.